So in the last lesson we dilated segments and rays and lines. In this lesson we're going to look at dilating angles. So given angle PQR, we want to draw P prime, Q prime, R prime, and that's the image after dilation about the origin of 2. So I'm dilating through the origin, which means I'm going to use my dilation rules. My original point P is at 4, 6. So P prime is going to be at 8, 12. My original Q is at 2, 1. So Q prime is going to be at 4, 2. R is at 8, 2. So R prime is going to be at 16, 4. So I can graph these points. P prime is at 8, 12. So up here, there's P prime. Q prime is at 4, 2. And R prime is at 16, 4. Again, you'll draw straighter lines than I will. So there's my dilated image. What do we know about the segment relationships? Well, it doesn't matter where the center is. We know from our work in the last lesson that QR has to be parallel to Q prime R prime, and QP has to be parallel to Q prime P prime. And we also know that their lengths are doubled. So if the lines are parallel, we want to think about what can we conclude about the angles. Well, if lines stay parallel, that means the angles have to be congruent, because the angles, the relationship, the angles haven't changed at all, because parallel lines have the same slope, which means the angle measurement between them will stay the same. So what we conclude is the fact that angle PQR has to be congruent to angle P prime, Q prime, R prime. So when we dilate an angle, we get the same angle measure. The angle measure does not change. So we can apply this knowledge and dilate a line, and we can do this even off the grid. So here's the first example. The line y equals 2x minus 4 is dilated by a scale factor of 3/2 centered at the origin. I want to write the equation that represents the image of the line after the dilation. Well, when you think about a line, 2x minus 4, and it being dilated, again, you're going to get a parallel line. So my original line equation, y is equal to 2x minus 4. Remember, the coefficient in front of the x, that's the slope. The constant term, that's the y-intercept. So when I dilate a line, the slope remains the same, but the y-intercept is going to change, because that's what happens. The slope is like the angles that don't change, and then the y-intercept is going to change depending on the scale factor. So all we have to do here, so the slope does not change. That's what you have to remember. The only thing that dilates is the y-intercept. So the point 0, negative 4 is going to undergo a dilation from the origin of 3/2, which means I multiply both values by 3/2, and you end up with 0, negative 6. So the new line equation, y is equal to 2x minus 6. The slope does not change. That yields a parallel line with a different y-intercept. So let's look at the next equation, or next example. The equation of line H is 2x plus y is equal to 1. Let's write this down here. 2x plus y is equal to 1. Line M is the image of H after a dilation, scale factor of 4 with respect to the origin. So here's my rule. Dilation from the origin, scale factor of 4. And I want to find the equation of the new line. This is just like the other example. What you have to do first is get this into y equals mx plus b form. So slope-intercept form, which means I'm going to subtract 2x from both sides. And here's my line. Y is equal to negative 2x plus 1. So my slope is negative 2. He's going to stay negative 2. My positive 1, that's the y-intercept, so he has a coordinate of 0, 1. I'm going to apply that dilation to that coordinate, and he's going to end up at 0, 4. So my new equation is y is equal to negative 2x plus 4. The only thing that changes is the y-intercept. Alright, since we know that dilations of line segments or lines produce parallel lines, we can use that in a little proof. So here's what we're given. We're given a dilation from center O by a scale factor of r. Maps angle BAC to B prime A prime C prime. So my center is probably down here somewhere. I don't think the center really matters because we're going to use the fact that dilations produce parallel lines. I want to show that angle A is congruent to angle A prime. Kind of what we just did. We already talked about this, but we're going to do this in a little proof. So here we go. It's going to be slightly informal. If I look at these lines here, the first statement I'm going to say is the fact that AB is going to be parallel to A prime B prime, and AC is going to be parallel to A prime C prime. So that's my first statement. AB is parallel to A prime B prime, and AC is parallel to A prime C prime. I'm going to use a flow proof today. And that's because dilations of segments produce parallel segments. Something like that. Alright, so if they're parallel, I can start labeling some angles here. So I'm going to call this angle 1, angle 2, and angle 3. This looks very similar to what we did in the very beginning of the year. Alright, if these two are parallel, that means angle 1 and angle 2 are corresponding angles. Therefore they're congruent, and angle 2 and angle 3 are corresponding angles. So they are congruent. So angle 1 is congruent to angle 2, and angle 3 is congruent to angle 2. Alright, I'm arrowing that because my parallel leads to that statement. If parallel lines are cut by a transversal, corresponding angles are congruent. I can't spell corresponding. Are congruent. And we only have one more thing. If two things are parallel or congruent to the same thing, then they are congruent to each other. That's the transitive property, or you could probably also get away with substitution. So that's my last step. Angle A is congruent to angle A prime. The reason is the transitive property. If two things are equal to the same thing, they're equal to each other. That's transitive. Okay, so we've just proven that if you dilate an angle, you get a congruent angle. So finally, we're going to look at scale factors, but we're really going to be doing this in class. Find the scale factor for each of the diagrams below and show that the scale factor holds true for each side of the figure. So what we'll do, we will, in class, we're going to calculate the scale factor and then take some measurements from like OA to OA prime and make sure that it holds true for each one of these examples. So this one we're going to finish up when we get to class.